There are various strategies that you can use to incrementally refactor your monolithic application into a set of microservices. And the first one I'm going to talk about is something I call the stop digging strategy. So the idea is that when you're in a hole, what you need to do is stop digging, stop making the problem worse. I actually recently discovered that this has a name. It's the law of holes. So if you go look that up on Wikipedia, there's quite an interesting entry. And the big idea is whenever it's time to implement new functionality, which means writing more code, don't implement that new functionality in the monolith. Instead, what you want to do is build a nice, pristine microservice that does that. And then you're going to put a router in front of your application, which will route new requests to the service, route old requests to the monolithic application. And then the final piece is you're going to need some glue code to integrate the new service back in with the monolith. Because almost always the service is going to need access to data that is owned by the monolith, and in some cases vice versa. So that's the big idea. It sounds quite simple in theory, but in practice, because there are these dependencies, actually building this anti-corruption layer can be quite challenging. Basically, the anti-corruption layer, as it's called, has to basically replicate data between systems. So for instance, the new service might need data that's owned by the legacy system. So the glue code could either query the legacy system, or it could replicate data into a database that is owned by the service, and then keep those two databases in sync. The new service might also want to update data that's owned by the legacy system. So the glue code could make a request to the legacy system, or even access the database of the legacy system directly, or it could actually update its own local copy and synchronize it with the monolith's database. So there's a whole bunch of interesting issues. And later on, I'm going to describe the design of the anti-corruption layer in a little bit more detail, and then also show a simple code example of how you could go about implementing it.